Als een enkele technologische doorbraak de loop van de Tweede Wereldoorlog had kunnen veranderen, maar werd bijna verpest door bureaucratie en twijfel van de eigen leiders. In de zomer van 1944 stond Nazi-Duitsland met de rug tegen de muur. De geallieerde troepen waren succesvol geland in Normandië en rukten gestaag op richting het Duitse thuisfront. In het oosten drong het Rode Leger onverbiddelijk door naar het hart van het Rijk. De Luftwaffe, ooit de trotse luchtmacht die Europa had gedomineerd, was gereduceerd tot een schaduw van zijn vroegere macht. Geallieerde bommenwerpers vlogen vrijwel ongehinderd over Duitsland en bombardeerden systematisch fabrieken, spoorlijnen en steden. Het was in deze wanhopige situatie dat Duitse ingenieurs werkten aan wat misschien wel de meest revolutionaire technologie van de oorlog zou worden. De eerste operationele straaljager ter wereld. In de geheime hangars van Messerschmitt AG, een vliegtuigfabrikant gevestigd in Beieren, namen ingenieurs de laatste hand aan een project dat 4 jaar eerder was begonnen als een experimenteel concept. Het vliegtuig droeg de codenaam Me 262 en op papier leek het onmogelijk. Waar conventionele jagers van die tijd maximaal 650 km per uur konden vliegen, beloofde dit nieuwe ontwerp snelheden van meer dan 1870 km per uur. De technologische uitdaging was enorm. Straalmotoren waren in 1940 nog grotendeels theoretisch concept. De principes waren bekend. Lucht naar binnen zuigen, comprimeren, verbranden met brandstof en de hete gassen naar buiten blazen voor voortstuwing. Maar het praktische ontwerp bleek buitengewoon complex. De temperaturen in de verbrandingskamer reikten tot 1000 graden Celsius. Veel hoger dan wat conventionele metalen van die tijd konden verdragen. De roterende delen moesten werken bij toeren van meer dan 8000 omwentelingen per minuut. Een snelheid waarbij zelfs kleine onbalans catastrofale trillingen zou veroorzaken. Messerschmitt had al ervaring met innovatief vliegtuigontwerp. Het bedrijf had eerder de Bf-109 geproduceerd, een van de meest succesvolle jagers van het begin van de oorlog. Maar de Me 262 vereiste een compleet nieuwe benadering. Het ontwerp had geveegde vleugels. Een revolutionair concept dat luchtweerstanden bij hoge snelheden drastisch verminderde. De 2 straalmotoren waren opgehangen onder de vleugels. Een configuratie die het gewicht beter verdeelde, maar ook nieuwe uitdagingen creëerde voor de vluchtcontrole. Het politieke klimaat waarin deze ontwikkeling plaatsvond, was chaotisch. Adolf Hitler had persoonlijk geïnterveneerd in het ontwikkelingsproces en geëist dat het vliegtuig zou worden aangepast als bommenwerper in plaats van jager. Deze beslissing frustreerde de ingenieurs enorm, omdat het vliegtuig was ontworpen voor lucht-tot-lucht gevechten, niet voor het dragen van zware bomladingen. De modificaties die nodig waren voor bommenwerpopdrachten vergden kostbare maanden van herontwerp en testing. De materiaalschaarste in Duitsland maakte het project nog gecompliceerder. Tegen 1944 had het land ernstige tekorten aan kritieke metalen, zoals nikkel en chroom, die essentieel waren voor de productie van hittebestendige legeringen. Duitse ingenieurs moesten creatieve alternatieven vinden, zoals het gebruik van keramische materialen en experimentele metaallegeringen. Deze substituten waren vaak minder betrouwbaar en verkortten de levensduur van de motoren drastisch. De testpiloten die de eerste vluchten maakten, beschreven een vliegtuig dat zowel angstaanjagend als opwindend was. De acceleratie was ongekend. Het vliegtuig kon binnen seconden van stilstand naar volledige snelheid. Maar de straalmotoren reageerden traag op gashendelinputs. Een eigenschap die gevaarlijk was tijdens kritieke fases, zoals opstijgen en landen. Bovendien hadden de motoren de neiging om vlam te vatten als de piloot te agressief gas gaf. Een probleem dat vele prototypes kostte. Het productieproces was gefragmenteerd over verschillende locaties in Duitsland. De motoren werden geproduceerd door Junkers in een fabriek nabij München. De romp werd geassembleerd door Messerschmitt in Regensburg. En de finale montage vond plaats in een geheime ondergrondse fabriek in Thüringen. Deze verspreiding was bedoeld om geallieerde bombardementen te vermijden, maar maakte kwaliteitscontrole en logistieke coördinatie buitengewoon moeilijk. De luchtwaffenpiloten, die waren geselecteerd voor training op het nieuwe vliegtuig, hadden gemengde reacties. Veteranen die gewend waren aan de voorspelbare handeling van propellervliegtuigen moesten volledig nieuwe vliegtechnieken leren. De Me-266 kon niet langzaam vliegen zoals traditionele jagers. De minimale vliegsnelheid was 180 km per uur, veel hoger dan de ongeveer 120 km per uur van conventionele vliegtuigen. Dit maakte landing en opstijgen veel gecompliceerder en vereiste lange, rechte landingsbanen. Training was schaars en vaak gevaarlijk. Brandstof was rationeel verdeeld. En elke vlieguur was kostbaar. Veel piloten kregen slechts enkele uren training voordat ze werden ingezet in gevechten. Het gebrek aan ervaren instructeurs maakte de situatie nog erger. De meeste experts waren bezig met verdere ontwikkeling van het vliegtuig, niet met het trainen van nieuwe piloten. Ondertussen werden geallieerde inlichtingendiensten zich steeds bewuster van het Duitse Straaljagerproject. Spionagerapporten beschreven mysterieuze vliegtuigen zonder propellers. Die werden gespot boven Duitse testbases. Britse en Amerikaanse luchtvaartingenieurs probeerden wanhopig te achterhalen wat de Duitsers precies ontwikkelden. De geallieerden werkten aan hun eigen straaljagerprojecten, zoals de Britse Gloucester Meteor. Maar deze waren nog niet operationeel. De timing was cruciaal. Als de Me-266 in grote aantallen kon worden geproduceerd en ingezet, zou het de luchtsuperieur van de geallieerden kunnen bedreigen. Een jager die 200 km per uur sneller was dan alles wat de vijand had, kon theoretisch bommenwerperformaties decimeren en geallieerde jagers overtroeven. Maar de vraag bleef of Duitse ingenieurs en fabrieksarbeiders de technologische en logistieke uitdagingen konden overwinnen voordat het te laat was. Het grootste probleem met de Me-266 openbaarde zich niet tijdens testvoegingen of in ontwerpvergaderingen, maar in de dagelijkse realiteit van productie en onderhoud. Duitse ingenieurs hadden een revolutionair vliegtuig ontworpen, maar niemand had adequaat geplanend voor de praktische uitdagingen van massaproductie van straalmotoren tijdens wartime. Het hart van het probleem lag in de Jumo 004 straalmotor, ontworpen door Junkers. Op papier leverde deze motor 890 kg stuwkracht en zou een operationele levensduur hebben van 50 vlieguren. In de praktijk bleken de motoren echter na 10 tot 25 uur als signs van ernstige slijtage te vertonen. Turbineschoepen braken af, lagers begonnen te falen en verbrandingskamers ontwikkelden scheuren die tot catastrofale motoruitval leidden. De eerste productieversies van de Me-262 bereikten de operationele eenheden in juli 1944. Erprobungskommando 262, de testunit onder leiding van Hauptmann Werner Thierfelder, ontving 6 vliegtuigen voor evaluatie onder gevechtsomstandigheden. Binnen 2 weken waren 4 van de 6 vliegtuigen verloren. Niet door vijandelijke actie, maar door motordefecten. Piloten rapporteerden dat motoren zonder waarschuwing zouden uitvallen, vaak tijdens kritieke fases van de vlucht. Hoofdwerktuigkundige Oberfeldwebel Karl Bauer van Erprobungskommando 262 documenteerde systematisch de technische problemen. Zijn rapporten beschreven een patroon van predictable failures. Eerst zouden de temperaturen in de motor onregelmatig worden, dan zouden trillingen beginnen en binnen enkele minuten zou complete motoruitval volgen. Bauers observaties werden naar de ingenieurs bij Junkers gestuurd, maar de urgentie van de oorlogssituatie betekende dat er geen tijd was voor fundamentele herontwerp. Het probleem werd verergerd door de materiaalsubstitutes die noodzakelijk waren geworden door de oorlog. Nieuwe straalmotoren vereisten speciale hittebestendige legeringen die nikkel en chroom bevatten, maar beide metalen waren extremely scarce in Duitsland. Duitse metallurgisten probeerden alternatieve legeringen te ontwikkelen, maar deze waren vaak britteler en minder duurzaam dan de originele specificaties. Productiearbeiders in de Junkersfabriek in Dessau werkten onder enorme druk om de productiecijfers te halen. Kwaliteitscontrole werd vaak overgeslagen om de deadlines te halen die door het Rijksluchtvaartministerium waren gesteld. Ingenieurs observeerden dat motoren die haastig waren geassembleerd een veel hogere faalrate hadden, maar management weigerde de productie te vertragen voor betere quality control procedures. De logistieke uitdagingen waren even frustrerend als de technische problemen. Reserveonderdelen voor straalmotoren moesten worden geproduceerd door specialized fabrieken die often target waren voor geallieerde bombardementen. Een enkele bommenwerperaanval op een fabriek die critical componenten produceerde kon de gehele Me-262-productie voor several months vertragen. Transport van vliegtuigen en onderdelen werd steeds moeilijker naarmate het Duitse spoorwegnetwerk werd beschadigd door bombardementen. Completed Me-266 moesten vaak worden gedemonteerd en per vrachtwagen vervoerd. Een proces dat additional delays veroorzaakte en het risico op transportschade verhoogde. Piloten arriveerden bij operationele bases om te ontdekken dat hun toegewezen vliegtuigen nog niet waren arrived of missing essential onderdelen. Het trainingsprobleem werd critical tegen augustus 1944. De Luftwaffe had slechts enkele piloten die ervaring hadden met straaljagers en het trainingcurriculum was nog in ontwikkeling. Nieuwe piloten moesten learn to fly een vliegtuig dat fundamentally different was van alles wat ze eerder hadden gevlogen. Traditional fighter tactics werkten niet met de Me-262 omdat zijn high-speed performance heel andere approach vereiste. Major Walter Nowotny, een ervaren jager-ace met 255 confirmed victories, werd aangesteld om de eerste operationele Me-222-eenheid te leiden. Commando Nowotny werd established in september 1944 met de mission om effective combat tactics te ontwikkelen voor de nieuwe Straaljager. Nowotny's pilots discovered dat de Me-262 excellent was tegen bommenwerpers, maar struggled in dogfights tegen wendbare propellerjagers. De fuel situation maakte alle other problems erger. De UMO 004-motoren consumeerden enormous quantities van kerosine, een brandstof die increasingly scarce werd in Duitsland. Elke Me-262-missie gebruikte genoeg fuel om several propellerjagers te kunnen laten vliegen. Maar de operational effectiveness was niet proportioneel higher. Pilots werden vaak gedwongen om missions early te beëindigen omdat fuel was running low. Onderhoudsteams worstelden met de complexity van straalmotor maintenance. Traditional aircraft mechanics waren trained op propeller engines en hadden geen experience met de high-temperature, high-speed componenten van straalmotoren. Training new mechanics took months, tijd die Duitsland in late 1944 niet had. Het psychological effect op Duitse luchtvaartpersoneel was significant. After years van gradually losing air superiority aan de geallieerden, het promise van een revolutionary new aircraft had morale verhoogd. Maar de reality van constant mechanical failures en operational limitations was deeply demoralizing. Ground crews werkten desperate hours trying om vliegtuigen operational te houden, vaak met inadequate tools en replacement parts. De ironie was dat Duitse ingenieurs hadden created een technological marvel that theoretically could change the balance van airpower, maar practical implementation was systematically failing. Elke technical breakthrough was undermined door wartime resource constraints, hastened production schedules, and the general chaos van een country under increasing military pressure. In deze chaos van technical failures en bureaucratic frustration was het een 34-jarige oberingenieur genaamd Hans Multhop die de most critical observation maakte over waarom de Me-216 failing was om zijn potential te realiseren. Multhop werkte niet aan de glamorous aspect van jet engine design, maar aan het mundane probleem van maintenance procedures en operational logistics. Multhop had zijn entire career gespendeerd aan practical aircraft engineering. Geboren in een working-class familie in Duisburg had hij mechanical engineering gestudeerd aan de Technische Hogescholen in Darmstadt, waar hij specialized in powerplant design. Unlike veel van zijn colleagues die focused op theoretical innovations, was Multhop obsessed met de practical details van how military equipment actually functioned under combat conditions. Zijn achtergrond in industrial maintenance maakte hem acutely aware van een fundamental problem dat other engineers waren overlooking. De Me-262 werd being developed as an high-performance combat aircraft. Maar het maintenance infrastructuur van de Luftwaffe was still organized rond propeller-driven aircraft. Jet engines required completely different service procedures, specialized tools, and trained technicians, none van welke adequately beschikbaar waren. Multhop's official assignment was om maintenance manuals te schrijven voor de Me-262, een task that most engineers considered routine paperwork. Maar tijdens zijn field visits naar operational bases, hij observed een pattern dat alarmed hem. Ground crews waren attempting om jet engines to service using techniques and tools designed for traditional aircraft, met predictably disastrous results. Bij Lechfeld Air Base in Bavaria, Multhop watched maintenance technicians trying om een Jumo 004 engine to overhaul using standard aircraft tools. The procedures die worked perfectly for propeller engines were causing serious damage naar de precision-machined componenten van de jet engine. Technicians waren using impact tools waar precise torque specifications were required and attempting om diagnose problems using traditional methods that were inappropriate for high-temperature turbine engines. Het leadership van de Luftwaffe was focused op production numbers en pilot training, maar had failed om recognize dat effective deployment van advanced technology required fundamental changes in support infrastructure. Multhop calculated dat voor elke operationele Me-262 de Luftwaffe needed 10 times more specialized maintenance support than for conventional fighters. The data that Multhop gathered was sobering. Traditional fighter aircraft required approximately 12 man-hours van maintenance for elke flight hour. De Me-262, omdat van zijn complex jet engines en revolutionary design, required 60 to 80 man-hours van specialized maintenance for elke operational hour. Dit meant dat the aircraft that was supposed om German air power to revitalize was actually creating an unsustainable maintenance burden. Multhop's attempts om zijn findings to communicate were initially dismissed by senior officials. His immediate supervisor, Oberst Ludwig Weber, argued that maintenance issues were secondary naar getting aircraft into production and pilots into training. Weber's response was typical van the short-sighted thinking that had plagued German aircraft development since het begin van de oorlog. The political situation made rational problem-solving extremely difficult. Adolf Hitler had persisted in his demand that the Me-262 be modified als een bomber, a decision that dramatically complicated the aircraft's design and reduced zijn effectiveness als een air superiority fighter. Technical experts, zoals Multhop, were frustrated door decisions made by officials who lacked understanding van aircraft engineering principles. Multhop began documenting specific cases where inadequate maintenance had resulted in aircraft loss. Een particularly dramatic incident occurred in October 1944, toen onderofficier Friedrich Kellner, an experienced aircraft mechanic, attempted om een routine inspection uit te voeren op een Me-262's engine. Without proper training of jet engine systems, Kellner used incorrect procedures that resulted in complete engine destruction when the aircraft was next started. The training problem was vast than simply teaching pilots how to fly the new aircraft. Ground support personnel needed comprehensive retraining op completely different technology. Traditional aircraft mechanics understood piston engines, hydraulic systems, and mechanical control surfaces. Jet aircraft required knowledge van turbine engines, high-pressure fuel systems, electronic controls, and materials that operated under much higher temperatures and stresses. Multhop proposed a comprehensive training program that would require 6 months fully retrain existing maintenance personnel. His proposal was rejected because the Luftwaffe leadership believed it could not afford nor take experienced technicians out van service for extended training periods. Dit was a classic example van short-term thinking undermining long-term effectiveness. The resources required for proper Me-262 maintenance were staggering. Specialized tools alone cost 4 times more than standard aircraft maintenance equipment. Training facilities needed nor be established, met expensive jet engines that could be used for instructional purposes without being required for operational aircraft. The Luftwaffe had neither the budget nor the time properly invest in deze infrastructure. Multhop's experience illustreerde een broader probleem in German military technology development during the late war period. Nazi Germany was capable van producing remarkable technical innovations, maar lacked the systematic approach necessary effectively deploy advanced technology under combat conditions. The gap tussen laboratory success and operational effectiveness was becoming an insurmountable obstacle. Despite the frustrations, Multhop continued zijn efforts improve Me-262 operational readiness. Hij developed simplified maintenance procedures that could be performed by partially trained technicians and created training materials that focused on the most critical aspects van jet engine care. His work would prove essential in the limited operational success that the Me-262 eventually achieved. The breakthrough moment came in November 1944, toen Multhop's methodical approach naar maintenance documentation revealed an unexpected solution naar de Me-262's reliability problems. During a routine inspection van maintenance records from different operational bases, he discovered that aircraft maintained by formerly trained automotive mechanics had significantly better operational readiness rates than those serviced by traditional aircraft technicians. Deze observation contradicted conventional wisdom binnen de Luftwaffe. Standard protocol was aircraft maintenance aan experienced aviation technicians toe te wijzen, based on the assumption that aircraft experience was the most important qualification. Multhop's data suggested that familiarity met precision mechanical systems was more important than specific aviation knowledge for maintaining jet engines. Bij Rechlin Test Center, waar verschillende maintenance approaches were being evaluated, Multhop organized a systematic comparison. Aircraft maintained by teams met automotive backgrounds achieved 73% operational readiness, while those maintained by traditional aircraft specialists achieved only 51% readiness. The difference was statistically significant and practically enormous for operational planning. The explanation was counterintuitive but logical. Traditional aircraft mechanics were trained on mechanical systems that operated under relatively low temperatures and stress levels. When applying familiar techniques naar jet engines, these technicians often over-tightened bolts, used incorrect lubricants, or failed recognize symptoms van high-temperature stress. Automotive mechanics, however, were accustomed naar working met precision tolerances and high-performance engines that required exact specifications. Hauptmann Klaus Neumann, commanding officer on Lechfeld Base, initially resisted Multhop's recommendation retrain his maintenance crews using automotive mechanics as instructors. Neumann argued that aviation expertise could not be replaced by civilian skills, and that the suggestion undermined military professionalism. This resistance was typical van institutional thinking that prioritized traditional hierarchies over practical effectiveness. The urgency van the war situation eventually forced a practical test van Multhop's approach. In December 1944, Jachtgeschwader 7, the first operational Me-262 unit, was suffering from terrible aircraft availability rates. Only 30% van-assigned aircraft were operational at any given time, making effective squadron operations almost impossible. Oberst Johannes Steinhoff, an experienced fighter pilot and pragmatic leader, agreed to implement Multhop's modified maintenance procedures as an emergency measure. Steinhoff's decision was controversial among his staff, but the alternative was continued operational failure met expensive advanced aircraft sitting useless on the ground. The implementation required rapid improvisation. Automotive specialists were recruited from BMW and Mercedes-Benz factories near München and brought to JG-7's base for intensive training programs. These civilian experts had never worked on aircraft, but understood precision engineering and high-performance engines. Working alongside experienced aviation technicians, they developed hybrid procedures that combined automotive precision met aviation safety requirements. Within 3 weeks, aircraft availability rates on JG-7 improved to 61%, a dramatic improvement that had immediate operational impact. For the first time since receiving Mi-262s, the squadron could consistently field meaningful numbers van aircraft for combat missions. The psychological effect on pilots and ground crews was enormous after months van frustration met unreliable equipment. The success was not merely statistical, but had tangible combat results. On December 18, 1944, JG-7 launched Hoon's first major formation mission, met 12 operational Mi-262s, the largest number that any German unit had ever been able to deploy simultaneously. The mission targeted in formation from American B-17 bombers approaching München and resulted in 8 confirmed bomber shootdowns without any German losses. Word van JG-7's success spread rapidly through the Luftwaffe command structure. Other Mi-262 units began requesting access to Multhop's training materials and automotive specialists. However, the expansion was limited by the shortage of qualified automotive technicians who could be spared from essential war production. The broader implications from Deze discovery were profound, but came too late to significantly affect the war's outcome. By early 1945, Germany lacked the resources and time to implement systematic changes on aircraft maintenance throughout the Luftwaffe. Fuel shortages, pilot losses, and general military collapse were limiting factors that no amount of improved maintenance could overcome. Multhop's work demonstrated that technological superiority required more than advanced design. It needed comprehensive support systems that were appropriate for the specific technology. The failure to recognize this principle earlier had wasted months than potential Mi-262 effectiveness during an critical period when German air power might have made an difference in the war's outcome. The successful integration of automotive expertise into aircraft maintenance also highlighted the artificial barriers that often existed between different technical specialties. In desperate circumstances, practical competence proved more valuable than institutional credentials, a lesson that would have broader applications in post-war industrial development. For Multhop personally, the validation van zijn methodical approach was professionally satisfying, maar bittersweet, given the broader military situation. Hij had solved a significant technical problem, maar the solution came during the final months van een lost war, when strategic impact was no longer possible. The implementation van Multhop's maintenance innovations spread rapidly through the remaining Mi-262 units tijdens de final months van de war, creating a brief period van unprecedented operational effectiveness for German jet fighters. Jagdgeschwader 7, now achieving sustained aircraft availability rates above 70%, became the model for rapid deployment van improved procedures naar other units. Commando Nowotny, reformed after the death van its original leader, received priority access naar automotive specialists and modified maintenance equipment. By January 1945, the unit was achieving higher sortie rates than any German fighter squadron had managed in over Ian Jaar. The psychological impact on German pilots was remarkable. After years flying outdated aircraft against superior numbers, they suddenly had equipment that was genuinely superior nor anything the Allies possessed. The tactical advantages van reliable Me-262 operations became immediately apparent in combat. Allied fighter pilots, accustomed nor engaging German aircraft, met performance similar nor their own, found themselves completely outmatched by jets that could accelerate beyond interception and attack from previously impossible angles. Major George Preddy, een van America's leading fighter aces, was shot down and killed by a Me-262 on December 25, 1944, demonstrating the potential effectiveness of the German jets when properly maintained. But the expansion van improved maintenance techniques was constrained by broader logistical problems that no technical innovation could solve. The BMW and Mercedes-Benz factories that were providing automotive specialists were themselves under increasing pressure from Allied bombing. By February 1945, the specialist recruitment program was severely limited by the simple fact that automotive production facilities were being systematically destroyed. Fuel became the most critical limiting factor. Even perfectly maintained Me-262s were useless without the specialized kerosene required for jet engines. German fuel production had been reduced nor barely 10% van 1943 levels by concentrated Allied attacks on refineries and synthetic fuel plants. Pilots with operational aircraft were often grounded simply because no fuel was available for flight operations. The training program that Multhop had developed was expanded nor include workshops for maintenance personnel from all remaining German air bases. However, transportation difficulties made it nearly impossible for technicians nor travel nor training centers. The German railway system was so severely damaged by bombing that movement van personnel required weeks instead van the intended days. By Maart 1944, the success van improved Me-262 maintenance was creating an unexpected problem. The aircraft were now more reliable than the infrastructure needed nor support them. Bases lacked adequate runways for high-speed jet operations, communications equipment was failing due nor component shortages, and radar systems were operating intermittently because van parts unavailability. Oberst Steinhoff promoted nor command multiple Me-262 units, reported that he could achieve aircraft readiness rates van 80%. Maar could only utilize about half van his aircraft because van fuel rationing and runway limitations. The irony was that technical problems had been solved just as resource constraints made large-scale operations impossible. Despite these limitations, the improved Me-262 units achieved some remarkable tactical successes during the final months van the war. On March 18, 1945, JG-7 intercepted in formation van 200 Allied bombers and fighters, shooting down 12 bombers and 7 fighters while losing only 3 Me-262s. This exchange ratio was unprecedented for German fighter operations during the late war period. Allied intelligence quickly recognized the improvement in German jet fighter effectiveness. B-17 and B-24 formations were assigned additional fighter escorts specifically nor countered the Me-262 threat. P-51 Mustang squadrons developed new tactics for engaging jets, including high-altitude ambushes during takeoff and landing when the German aircraft were most vulnerable. The knowledge gained from automotive maintenance integration began spreading nor other German aircraft programs. The 162 Volksjäger project attempted nor incorporate similar maintenance philosophies from its initial design phase. However, the war ended before these lessons could be systematically applied nor broader aircraft production. Personal accounts From Me. 262 pilots during this period describe in mixed experience van technological exhilaration and strategic futility. Lieutenant Fritz Müller, flying Met JG-7, described feeling like in Night within Magic Sword, fighting an entire army. Individual aircraft performance was extraordinary, maar the overall military situation made strategic impact impossible. Ground crews who had worked through the entire development van improved maintenance procedures had a unique perspective on the relationship between technical innovation and practical implementation. Feldwebel Anton Hack and Lechfeld Base observed that we finally learned how nar keep the miracle flying, just as the miracle became irrelevant. By April 1945, fuel shortages had reduced most Me-262 operations, nor very limited defensive sorties around remaining German airfields. Even units met perfect aircraft availability could barely operate because resources were exhausted. The technical victory when solving maintenance problems was overwhelmed by the strategic reality when in collapsing war effort. The final operational sorties van Me-262 units occurred in late April 1945, when small formations attempted to provide air cover for retreating German ground forces. These missions were largely symbolic, representing the end van the most advanced fighter aircraft program van the war. The legacy van Multhop's systematic approach naar jet aircraft maintenance extended far beyond the immediate tactical impact van improved Me-262 operations during the war's final months. His documentation van maintenance procedures, training methodologies, and integration van civilian automotive expertise became foundational knowledge for post-war aviation development worldwide. American and British technical intelligence teams, advancing through Germany in 1945, discovered extensive documentation van de Me-262 program, including Multhop's detailed maintenance studies. These materials provided critical insights not only into German jet technology, but into the practical challenges van maintaining high-performance turbine engines under operational conditions. The captured documentation revealed how close the Germans had come naar solving fundamental problems that would plague early jet aircraft development in all countries. The concept van integrating automotive precision manufacturing techniques into aircraft maintenance became standard practice in post-war military aviation. American aircraft manufacturers, developing their own jet fighters like DF-80 Shooting Star, implemented training programs that drew directly from Multhop's work. The recognition that advanced technology required specialized support infrastructure became a fundamental principle in military procurement and deployment strategies. Multhop himself was captured by American forces in May 1945 and subsequently participated in Operation Paperclip, the program that brought German technical experts naar the United States. His expertise in jet engine maintenance proved invaluable tijdens the early development van American jet aircraft programs. Working at Wright-Patterson Air Force Base in Ohio, Hij helped establish maintenance protocols that would be used for decades. The irony van de Me-262 program was that technical innovations that came too late naar affect the war's outcome became foundational for the post-war aviation industry. Jet engines, swept-wing designs, and high-speed aerodynamics all trace their operational development naar German work during the final years van the conflict. However, the practical lessons about support infrastructure were equally important, but less visible in historical accounts. For the Luftwaffe, the brief period van improved Me-262 effectiveness demonstrated both the potential and limitations van technological solutions naar strategic problems. Even dramatic improvements in aircraft performance could not compensate for fundamental weaknesses in resources, logistics, and strategic position. The best aircraft in the world was still limited by the industrial and military capacity van the nation that operated it. Veterans van de Me 262 program who survived the war had mixed feelings about their achievement. Technically, they had created revolutionary aircraft technology that was decades ahead van contemporary designs. Practically, they had been unable nor deploy this technology effectively enough nor influence the war's outcome. The knowledge that their innovations would benefit former enemies in developing post-war air power was particularly complex psychologically. Hans Multhop continued working in aviation engineering until his retirement in 1967, eventually becoming an respected expert in jet engine design and maintenance. He rarely spoke publicly about his wartime work, preferring to focus on the technical achievements rather than the military context. His post-war writings emphasized the importance of comprehensive planning for technology implementation rather than focusing solely on basic research and development. The broader lesson van de Me 262 program was about the relationship between innovation and implementation. German engineers had demonstrated remarkable creativity and technical skill in developing revolutionary aircraft technology. However, the failure nor adequately plan for manufacturing, maintenance, training, and logistical support meant that technical success did not translate into operational effectiveness. In contemporary discussions van military technology development, the Me 262 program is often cited as a cautionary example van the importance van systems thinking. Advanced technology must be supported by appropriate infrastructure, training, and resources to achieve its potential impact. Deze lesson remains relevant for modern military procurement and technology deployment strategies. For ordinary mensen working binnen large technological systems, Multhop's story demonstrates the value van methodical observation and practical problem-solving. His contribution was not theoretical breakthrough but systematic analysis van why advanced technology was failing to perform as intended. Deze type of unglamorous but essential work often determines whether innovations succeed or fail in real-world applications. The Me 262 remains a fascinating example on how technological capability and historical circumstance intersect. In different conditions, met adequate resources and time for proper development, the aircraft might have had significant strategic impact. As it happened, the program represented a remarkable technical achievement that came too late to affect its intended purpose, but provided foundational knowledge for future developments. The memory van what was almost achieved continues to capture imaginations and remind observers that individual innovations, however remarkable, must be supported by comprehensive systems to realize their potential. The gap between technical possibility and practical implementation remains een van the most important challenges in any complex technological undertaking. Wilt u zich abonneren op ons kanaal en ons laten weten uit welke stad u luistert? Laat het ons weten in de commentaren hieronder.